Hello and welcome back to another video on the Abacus 11 Plus YouTube channel. Today we are going through a real-life school maths paper. So a real school, the Aldenham school. We're going to go through their entire maths paper. We're going to work out all the questions so we know the solutions and we know exactly how to approach the problems. So let's get straight into it and see what we can learn. Okay, so here for our very first question, we have a very nice and easy one. Write the number 14,036 in figures. So here it's a very easy question. The main thing is not making any silly mistakes. So we have to make sure we read the question very carefully. 14,036. So we start with the 14,000. We use the comma to show the thousand. And then we have 36. So 0, 3, 6. No hundreds. 3 tens, 6 units. Very simple. 14,036. Let's move on to the next question. Next, we have a fill in the gaps question. So part A, let's start there. We have blank plus 15 equals 43. So how do we work this out? Well, we simply rearrange the equation. Right? If we have blank plus 15 equals 43, we want to end up with blank equals and then our number, right? We don't want blank plus or minus anything. We want blank on its own on one side of the equation and then a number on the other side of the equation. So how do we get to this position? Well, we have to rearrange this. And how do we rearrange it? Well, we have the left-hand side and we have the right-hand side. We're trying to remove this plus 15. And we can remove the plus 15 by minusing 15. So we minus 15 from both sides of the equation, because whatever we do to one side, we have to do to the other side. So here, on our left-hand side, let's make some more space. On our left-hand side, we have something, plus 15, minus 15, these two cancel out. So we have that thing we're looking for, the gap. And then on the right-hand side, we have 43 minus 15. Now, we can just simply work this out using mental maths. We know 43 minus 15 is the same thing as 43 minus 10 minus 5. And we can do that in our head. 43 minus 10 is 33. 33 minus 5 is 28. So we have 28. So our gap is 28. So now moving on to part B, we have 6 multiplied by something, our gap, equals 54. So how do we work this out? Same exact thing. We have left-hand side, we have right-hand side, and we want to end up with this squiggly thing on its own. We want to know what this is. And this squiggly thing could be X, it could be A, it could be anything. So this could be algebra as well. So same thing here. We're trying to reverse or remove this multiplication by 6. And how do we do that? We do that by doing the opposite. We divide by 6. And whatever we do to one side of the equation, we have to do to the other side of the equation. So we divide both sides by 6, create some more space. On the left-hand side, these two cancel. So we're left with our squiggly line. On the right-hand side, we have 54 divided by 6, which is 9. So here our gap is 9, and we should be getting the hang of this now. Now for part C, we have squiggly line, or I'm just going to call it X now. Minus 23 equals 57. Here we can skip the steps. We know what's going on. We're going to add 23 to both sides. So X equals 57 plus 23. So that's going to be 57 plus 20, which is 77. And then 77 plus the remaining 3, which is 80. So X is 80. And you can see how we're using mental maths, because if you can get good at mental maths, you become so much more efficient. We could have worked this out the normal column type addition way, and this would work. 7 plus 3, 10, so 0, carry the 1. 5 plus 2, 7, add the 1, 8. So the same answer of 80, but if you can get good at mental maths, it will help you be more efficient in your 11 plus maths exam. So either way, our answer is 80. And now for our final question, we have 64 divided by something equals 8. Now here, without even using any extra workings out. If you're good with your times tables, you know straight away. The answer has to be 8. Because we know 8 times 8, 8 squared is 64. So that means the reverse, 64 divided by 8, should be 8. So the answer is 8. So now for our next question, we have the Palladium can hold 2,175 spectators. If 305 of the seats are empty, how many of the seats are taken? So this is going to be a simple subtraction. So if we think about it, we have this huge hall and we have 2,175 spaces. Of those 2,175 spaces, 305 are empty. And if 305 are empty, that must mean the rest are taken. So all we do is take this 2,175 and we subtract 305. So it's a very simple question. It's just understanding the maths behind the question. And once you do that, you should be fine, because here we have 5 minus 5, which is 0. Then we have 7 minus 0, which is 7. Then we have 1 minus 3, which we can't do, so we borrow a 10 from the 2, make it 11 minus 3, 8. And then we have the 1 minus 0, so 1. So we have our answer is 1,870. So 1,870 seats are taken. 1,870. So here for our next question, we have a bottle of fizzy pop holds 750 milliliters. How many 150 milliliter glasses can be filled from this bottle? So here we have a division question. We must take the 750 milliliters and divide that by 150 to see how many 150s go into 750. Now, this has already been made pretty easy for us because both of these values are in milliliters. They have the same unit. So now it's a simple division. And we can take out the common factor of 10. So we remove the zeros, right? And then also, on this vertical line, we can take out the common factor of 5 because 5 goes into 15 3 times, right? 5 times 3 equals 15. So 5 goes into 15 3 times. And 5 also goes into 75. How many times? Well, if you think about it, 1 carry the 2, 5. So it's going to be 15 times. And then if we switch to a different color, we have the common factor of 3. 3 goes into 3 once and into 15 5 times. So we have 5 over 1 or 5. So the answer is 5 glasses. So here for this question, we have to be very careful to make sure that we put everything into the same units. So Katie's mom gives her £10, right? She spends £1.90. So let's first note down the £10. She spends £1.90 on magazines. So we're taking away £1.90 from that £10. She spends also £2.45 on a birthday card, taking away £2.45. And then also she spends 75p on chocolate. So taking away 0.75 pounds, right? 75p is 0.75 pounds. How much money does she have left? So we can do this with simple column subtraction. So let's start off with the £1.90. So we have £10 minus £1.90. We could do it like this. So 0 minus 0, 0. 0 minus 9 we can't do. So we take a 10 from the 1, take a 10 from this 0, 10 minus 9 being 1, and then 9 minus 1 being 8. £8.10. Or we could use mental maths, because if we're doing £10 minus £1.90, what's £1.90 very close to? It's very close to £2, right? It's almost £2. And we know pretty easily what £10 minus £2 is, right? It should be £8. But since we're not subtracting £2, but instead we're subtracting the lower amount of £1.90, we have to add back that 10 pence. So you would have £8, but instead we have £8 plus the remaining 10 pence. which is £8.10. Okay, so let's clear all this up. We know we're starting with £8.10. And once we have £8.10, we're now subtracting £2.45. Let's try and use our mental maths here. So £8.10, we're subtracting now £2.45 that she spent on a birthday card. Here, what's £2.45 very close to it? It's very close to £2.50. So we can do £8.10 minus £2.50. Well, £8.10 minus 2 whole pounds is going to be £6.10. But then minus the remaining 50 pence, and we're going to get not £6.10, but £5.60. £5.60. Right? We got £6.10 and we take away an extra 50 pence from the amount. So £5.60. And then we realize that we're not actually subtracting £2.50, but we're subtracting £2.45. So we add back that 5 pence. So here, we don't remain with £5.60, but we actually remain with £5.65. So £5.65 is our next value. And then, finally, we take off the 75 pence. So again, one last time, let's clear up our space. We have £5.65. And we're taking away 75 pence, 0.75. Here again, we can use mental maths. Why? Because this time we know that 75 pence is actually rather conveniently a combination of 65 pence and 10 pence. So if I change color here, we can see that we can start by taking away the 65 pence from £5.65, leaving us with £5. And then we can take off the remaining 10p, giving us £4.90. So how much money does she have left overall? The answer should be £4.90. So now here for question 6, part A says, what is 14 times 100? So here we know it, just be very careful. Add the 2 zeros, giving us 1,400. Then we have 864 divided by 100. So we have 864.0, same thing as 864. And we divide by 100. Just think about it as doing 2 bunny hops back, right? We're dividing by 100. So since we have 2 zeros, we're doing 2 bunny hops back. So it goes from the decimal point being here to the decimal point being here. So now we have 8.64. So that's our answer, 8.64. And then we have something times 300 equals 60. So we did a kind of question like this already. What do? We rearrange the equation. And we want to get this thing on its own. So we divide both sides by 300. So left-hand side, divide by 300. This should cancel. Right-hand side, we have 60 over 300. This is a very nice fraction here. So here we can take out some common factors, right? We simplify this by taking out common factors, numbers that go into both the numerator and the denominator. So take out the common factor of 10, very easy one to take out. We have 6 over 30. And then we can take out the common factor of 6. And here your times tables will always help you out. So 6 goes into 6, let's switch color, once. And 6 goes into 30 5 times. 6 times 5 is 30. So we have 1 over 5. So our question mark, our answer, is a fifth, 1 over 5. So here for this next question, we have look at the numbers in the start. We have a group of numbers, a set of numbers. Part A asks us which 2 numbers are multiples of 6. So multiples of 6. Think about your times tables. So we have 6, 12, 18, 24, 30, 36, so on and so forth, right? These numbers are all multiples of 6. So the way we can check that is by seeing if any of these numbers can be divided by 6. Because if they can be divided by 6, that means 6 times something equals that number. And if 6 times something equals a number, that number is a multiple of 6. So 9, no. 10, no. 12, yes, 6 times 2. So we have 12. And we already know here, we're looking for 2 numbers, right? We have 2 gaps. So the question is giving us a clue. So let's find the second one. And if you look carefully, it should be 30. Why? Because 6 times 5 is 30. So those are our 2 multiples of 6. Next one, which 2 numbers are prime? So you have to know what a prime number is. A prime number is a number that only has 2 factors, itself and 1, right? It can only be divided by itself and 1. So here, our first prime number should be 17. The only 2 factors of 17 are 17 and 1. And then our second prime number should be 29, right? Because 29, again, only has 2 factors. Itself, 29, and 1. So 29 is our second prime number. So now let's move into part C, and now we have which 2 numbers are factors of 60. So we've already gone through multiples, but what do we mean by factors? Well, a number will be a factor of 70 if 70 can be divided by that number and it leaves no remainders, right? So if we have 8, for example, and we divide 8 by 4, then since 4 times 2 is 8, we have a clean number. It's 2, no remainders. But if we try and divide that same 8 by 5, look what happens. Yes, 5 goes into 8 once, but then we have a remainder of 3. So the answer here would be 1 remainder 3. So whenever we have this remainder situation, that tells us that the number, 5 in this case, is not a factor of the other number. So here we're looking for factors of 70. And again, our times tables can help us, because if we use our times tables, we know the first one should be 10, right? Because 10 times 7 is 70, or rather 70 divided by 10 gives us 7, remainder 0, no remainders. So our first one should be 10. And what about our second one? Well, let's go through the numbers. It's not going to be 12, right? Because 12 times 5 is 60, then add 12 again is 72. However, 14 looks very promising because 14 times 5 is 70. 14 times 5. 4 times 5 is 20, so 0, carry the 2. 5 times 1 is 5, plus the 2 we carried over is 7, so 70. So if 14 times 5 is 70, that means 70 divided by 14 should give us 5, remainder 0, no remainders. Therefore, it's a factor, so 14 here. And finally, we have which 2 numbers are square numbers. So numbers that are square numbers, let's find it. The first one's going to be 9. Why? Because 3 squared is 9, and therefore 9 is a square number. And then also we have 49. Why? Because this time 7 squared is 49. So our 2 numbers, which are square numbers, are 9 and 49. Very big question there, but that's how we work it out. So here for this next question, let's be very careful with how we work it out, because there are a couple of traps laid for us. So let's go through it. George had a bag full of 24 apples, and he gave half of them to his granny to make an apple pie. Then he gave 2/3 of what was left to his friends, and then put the rest in the fruit bowl. So how many did he put in the fruit bowl? So let's start by going through the first bullet point. He gave half of his 24 apples to his granny to make an apple pie. So half of 24, we know of, the code word of that is times, multiplication. So half times 24 over 1, or 24, same thing. Here, we can work out how many apples this equates to, how many apples he gave to his granny, because we can simplify this equation by cancelling along this diagonal. Why? Because we have a common factor of 2. 2 goes into 2, and it also goes into 24. It goes into 2 once, and into 24 12 times. So here we have 1 over 1 times 12 over 1, or just 12. So he gave 12 to his granny. Then, bullet point 2, he gave 2/3 of what was left, which would be 12 apples, to his friends. So how many did he give to his friends? 2/3 of 12. Well, divide by this diagonal here, we have a common factor of 3. 3 goes into 3 once, into 12 4 times. So we have 2 over 1 times 4 over 1, or 2 times 4, 8. So he gave 8 to his friends. He didn't keep 8, he gave 8 to his friends. And that's important because it tells us we need to subtract 8 from the 12 he originally had to work out the rest that he has in his fruit bowl, because that's what the question is concerning. How many did he put in the fruit bowl? So it's 12 minus the 8 he gave to his friends, giving us 4 apples. So George put 4 apples in his fruit bowl. So here for this question, the whole point is to turn this text into maths. And if we can do that accurately, the answer should pop out. So let's try and work this out. Emily is thinking of a number, and let's call that a number x. What does Emily do to x? Well, first she adds 2 to it. She adds 2 to x. So we have x plus 2. Then she squares everything. So very important here, she's not squaring x, she's squaring everything, x plus 2. So we need some brackets, and we're squaring everything. And then she subtracts 4, and she gets 60. What number was Emily thinking of? To work out what number she was thinking of, we need to work out x. And to work out x, we need to end up with x on one side of the equal sign, on one side of the equation, and a number on the other side of the equation. So what do we need to do? We need to rearrange the equation. So let's get into this equation. And the right mindset to have is we know we need to end up with x equals something. So x on one side and the number on the other side. So what we need to do is remove all the obstacles blocking us from getting to x on its own. So the first obstacle is this subtraction by 4. So we can take that out or reverse it by adding 4 to both sides. So adding 4 to both sides gives us x plus 2 squared on the left-hand side and 64 on the right-hand side. Then we can square root both sides. Left-hand side, we have x plus 2. Right-hand side, we have the square root of 64, which is 8, because 8 squared is 64. Let's bring this up here so we have a bit more space. X plus 2 equals 8. Well, now we can subtract 2 from both sides. Let's put it in a nice bold red. And this gives us on our left-hand side what we wanted, x. And on the right-hand side, we have 8 minus 2, which gives us our magic number of 6. So now we know the number that Emily was thinking of is, or was, 6. So now we have to circle the smallest number in each group. So let's start with A. Well, straight away, we know to look at the tenths column, right? Because this number here, 0.309, is going to be bigger than this number here, 0.039, because in the tenths column we have 3, and here in the tenths column we have 0. So using this understanding, we can already disqualify this number here. And also we can disqualify 0.93. So let's move on to this final one. We have 0.093. So here for both of these numbers in our tenths column, we have a 0. So now let's move on to the hundredths column. Here we have a 3, but here we have a 9. Now because 9 is bigger than 3, this number here is going to be bigger than 0.039. And therefore, 0.039 is the smallest number. So this is how you work out the smallest number when you have decimals. It's not about which number has the most or the least number of numbers after the decimal point. It's more about going through the number step by step by going through the tenths column, hundredths column, thousandths column, so on and so forth. And this leaves us with our answer of 0.039. Let's make it nice and neat. 0.039. So now for part B, we have minus 7.5, we have minus 8, 2 and 0. So here the smallest number is going to be minus 8. Make sure you're very careful with this because we have this negative number. So therefore we're going in the negative direction. So as the numbers seemingly get bigger, they're actually getting smaller, right? Negative 1,000 minus 1,000 is smaller than minus 1. So here the smallest number is minus 8. Then for part C, the smallest number is going to be 1/8. And that's because if you understand what fractions actually mean, a fraction is simply a division. We're dividing the numerator, the top number, by the denominator, the bottom number. So the bigger the bottom number the denominator gets, the more pieces, the more slices we're cutting the numerator, the top number into. Think about it like a pizza. If you're at the restaurant with your friends and you have a whole pizza between two of you, you're each going to get a pretty good slice, right? You're not going to be too hungry. But if you share the same pizza, but you've brought 10 of your friends or 20 of your friends, you will leave that restaurant very, very hungry. Why? Because you split that one pizza into 20 slices rather than splitting it into 8 slices or 2 slices. So you can see as the number on the bottom, the denominator, gets bigger, the size of your pizza slice gets smaller. So here the smallest number is 1/8, an eighth. And now for part D, we have a mixture of fractions, decimals, and percentages. So first and foremost, we can cancel out 0.4. Let's not even think about it because we already know 0.22 is smaller than 0.4. So then we have 1/4, 0.22, 30%. Let's turn these all into fractions. That's the easiest thing to convert them into. And also the easiest thing to compare. So 30% is going to be 30/100. 0.22 is going to be 22/100. And 1/4 is going to be 25/100, right? We multiply both the numerator and the denominator by 25. So now they all have the same common denominator. It's very easy to compare the numbers because all we do is compare the numerators and the smallest numerator is 22. And therefore 0.22 is the smallest number. So here for this next question, we're told the temperature in Paris was 8 degrees Celsius lower than in London. What was that temperature? So we take London 5 degrees Celsius and we subtract 8 degrees Celsius. So we do 5 minus 8, giving us -3 or -3 degrees Celsius. And then for part B, what was the difference in temperature between Oslo and New York? So let's take a look at this. We have New York here and we have Oslo here. And we want the difference. So if we want the difference, we've got to think about the entire distance that we're stretching when going from -5 to 7. So if we start from 0, -5 is a negative number. So we're going to the left. So -5 should be somewhere here, right? -5. And then 7 being a positive number, let's keep the arrow there, being a positive number is going to go to the right-hand side. It's going to be somewhere over here, 7 degrees Celsius. So the mistake here would be seeing the number 7, seeing the number 5 and thinking, oh, the difference is 2. No, because we have 7 and -5, we have to go across the 0, which means the actual difference is first getting from -5 to 0, which is 5, and then going from 0 to 7, which is 7. So it's 5 plus 7, giving us 12 degrees Celsius. That's the actual difference in temperature. So here for this question, we're told that Freya scored 16 out of 20 in her spelling test, but Hannah scored 85% in her spelling test. So who did better? And we have to explain our answer. Now, the way we're going to work this out is either by working out the percentage that Freya got, or by working out how many marks that Hannah got. So in this case, it will be easier to work out the percentage that Freya got, and we'll see why. The reason why is because if we take her score, 16 out of 20, to work out what percentage that Freya got, we simply work out 16 over 20 multiplied by 100. Now we can take out the common factor of 20 across this diagonal, giving us 1 and 5. And then we simply do 16 times 5 to work out her percentage. Well, 16 times 5 is 10 times 5, and then 6 times 5. 10 times 5 is 50. 6 times 5 is 30. 50, 30, 80. So Freya scored 80%. And therefore, because she scored 80%, she scored less than Hannah, who scored 85%. So we can write something down. Let's say H, or let's say Hannah. Go on. Hannah did better because she scored 5% more than Freya. And we know this because Freya scored 80%. And that should be enough for our 2 marks. So here we have to fill in the missing numbers. So let's try and work out these sequences. And it's all going to be about pattern recognition. So we start with A, -3 to 1 to 5 to 9. Here, very simple one, we're adding 4 each time. So we add 4 to 9 to give us 13. And we add 4 to 13 to give us 17. Part B, 32 to 26. What's going on here? Well, to go from 32 to 26, what are we subtracting by? Well, going from 32 to 30 is minusing 2, or subtracting 2. And then going from 30 to 26, we're subtracting an extra 4. So overall, we're subtracting 6. So let's try and keep this pattern going. Let's subtract 6 from 26. This would give us 20. Then let's subtract 6 from 20, 14. Okay, so it seems like we found the pattern. Let's continue this pattern. 14 minus 6 gives us 8. So it's 20 and 8. Then for part C, it seems like we're doubling this time. We're timesing by 2. 3 to 6 is double. So 3 times 2 is 6. 6 times 2 is 12. What's 12 times 2? 24. Then we continue it. 24 times 2, 48. 48 times 2 is going to be 96. Then for part D, we have 1, 4, something, 16, 25, something. Okay, so here we have classic square numbers. 1 times 1 is 1. 2 times 2, or 2 squared, is 4. 3 squared is 9. 4 squared, 16. 5 squared, 25. 6 squared, 36. So 9 and 36, square numbers. Now here for question 14, we have to use some of our knowledge about angles. So let's try and work it out. Part A, estimate the size of angle A. So here, there's no real exact correct number because we have no values. But saying that, there is a range of values that will be acceptable. First of all, we have to understand that we have a straight line. And the angle on a straight line is going to be 180 degrees. And then we also know about right angles, right? Right angles are 90 degrees. So if we take the size of angle A over here, we already know that it has to be less than 90 degrees because 90 degrees is our right angle. And then if you also compare it to 90 degrees, it kind of looks halfway between our 90 degrees and our 0, right? All the way over here. So if we're halfway between 90 degrees and 0, then roughly we should be at 45 degrees. So here, there's no exact answer, but I would say for you to get the mark, your answer should be somewhere between 40 degrees and 50 degrees. So any value around there, most commonly being 45 degrees, would be correct. And we use our knowledge of angles on a straight line and our knowledge of right angles to work that out. And then for part B, we have use your own answer to part A to find the size of angle B. Okay, perfect. So we know angles on a straight line always equal 180 degrees. So if we have 45 degrees here, let's put it in red, 45 degrees, then to go the rest of the way around, all we do is 180 minus 45. And we can simply take this as 180 minus 40, giving us 140, and then we minus the extra 5, giving us 135. So the size of angle B, based on angle A being 45 degrees, will be 135 degrees. So here for this question, we have to make sure we are very careful and don't make any silly mistakes. So we start at 5:35 in the morning, right? That's when these football players, these students arrive at Heathrow Airport, 5:35. And we're trying to go from 5:35 in the morning to 8:10 in the morning. So let's start by going to 6 a.m. So 5:35 a.m. to 6 a.m. What's going on? We're simply adding 25 minutes, right? So let's put 25 minutes here. Or let's put 0025. So now we're at 6 a.m. Let's jump to 8 a.m. And doing this is a jump of 2 hours. So now we have not 25 minutes, but we have 2 hours and 25 minutes. And finally, let's go from 8 a.m. to 8:10, adding on 10 minutes. So now we don't have 2 hours and 25 minutes, we have 2 hours and 35 minutes. So that's our answer, but then we're told to put everything in minutes. So 2 hours is obviously going to be 120 minutes because there's 60 minutes in 1 hour. So 120 plus the 35 gives us 155 minutes, and that's our answer. Now, for this question, we have to fill in this chart. And the way we're going to do this is by first starting with the easy, quick wins. And those easy, quick wins will be found where there's only one unknown. So here, for example, we only have one unknown. We know that for tennis, in terms of favorite sports, it's the favorite sport for 5 boys, and overall, it's 13 students' favorite sport. And therefore, it has to be the favorite sport for 8 girls. Same thing for swimming. This has to be 10 because 6 plus something equals 16. And now we have a few less unknowns, and we can work out the total for girls. We have 8 plus 5 giving us 13, 13 plus 12 giving us 25, 25 plus 10 giving us 35. And now we can work out the total of the totals, right? We have 25 plus 35. So 25 for boys, 35 for girls, or 25 plus 5 is 30. 30 plus the remaining 30 is 60. Great. Now we can work out this unknown. So you see how we're going through the table systematically, trying to work out the situations where we only have one unknown. So here we have 13 plus something, plus 14, plus 16 equals 60. So let's work out 13, 14, 16. 13 plus 14 is going to give us 27. 27 plus 16 is going to give us, 27 plus 6 is 33. 33 plus the remaining 10 is 43. So we have these all adding up to 43. So to get to 60, our total, this has to be 17. And this allows us to work out the final few values, because this must be 12 to make this all add up, and this must be 2 to make this all add up. So that means we have now filled the table. So part A is complete. And now we have some probability. Okay, part B finds the probability that a student picked at random likes hockey best. Okay, so we're told we're looking for the probability that a student, girl or boy, likes hockey best. So to work out this probability, we take the total number that fit our criteria over the overall total. And if we do that correctly, we should come out with the correct probability. So let's try and use this framework. How many of these students fit our criteria? What is our criteria? Our criteria, our rules are that the student must like hockey best. Girl or boy, they must like hockey best. So here, there are 14 students that fit our rules, that fit our criteria. So 14 is our numerator. And then how many students is this out of? Well, because we're picking students out of students, our bottom number, the total number, should be the total number of students, which is 60. Right? So we have 14 over 60. This would be completely different if they said, find the probability that a boy picked at random likes hockey best, right? Or it said maybe out of all the boys, someone likes football best, right? That would change our criteria and change our total. But here, our criteria is going to be 14 because we're talking about students in general, girls and boys. And our total number is going to be 60 because, again, we're talking about a student out of all the students. So 14 over 60, and let's try and simplify this fraction. So this could be correct, you get the mark for it, but we can also write it in its simplest form. We can simply divide it by 2, 7 over 30. And by divide it by 2, we of course mean we can take out the common factor of 2 from both the numerator and the denominator. So 2 goes into 14 7 times, and 2 goes into 60 30 times. So 7 over 30. This is our probability. So now for this reflection question, let's try and work this out. So here we see our line of reflection is not horizontal, it's not vertical, it's diagonal. So we have to be very careful with how we reflect this. Let's start and take this line by line, right? Take it line by line, be very careful to make sure you don't make any silly mistakes. We start here. This line here is going vertically downwards, and it's hitting this diagonal line of reflection. And when it hits this diagonal line of reflection, it's going to go off in this direction, right? And how many squares is it going to go off? So this is 1, let me do it in blue. This is 1, 2, 3, 4 squares until we get to the line of reflection. So we do the same thing. We bunny hop. 1, 2, 3, 4. 4 bunny hops. And this brings us all the way here. Okay. Now we move on to the next part. And to be honest, instead of trying to work out this slanted bit here, which might be a bit hard, we can simply work out this bit here and do the same thing again. This time we have 1, 2, 3, 4 bunny hops again. So we can do 4 bunny hops in this direction, 3, 4. So we're going here. And now, if you were to find reflecting this part of the line hard, you don't have to think about it anymore, because we simply connect these two lines together, and that should be the reflection of this line. So you can see we've worked it out. This is the reflection of this shape given our awkward diagonal line of reflection. This is our answer. Okay, so for question 18, if the probability of it raining tomorrow is 0.08, what is the probability of it not raining? So whenever we see probability and we see not, we have to think a certain kind of way. And the reason is because in the world of probabilities, the maximum probability we can get is 1. And 1 represents certainty. If something has a probability of 1, we are certain that thing's going to happen. Same way, if it has a probability of 0, then we're certain it's not going to happen. It's impossible, right? So, knowing that, if we go back to this question, we're told the probability of it raining tomorrow is 0.08. So to work out the chance of it not raining, we take 1 certainty, put it in blue, take 1 and we subtract 0.08, which gives us 0.92. That's our answer. But it all comes from understanding how things work in the world of probabilities. 1 being certainty, 0 impossibility. So here we have a pie charts question, and part A says what fraction of people owned a black car. So here we can see very clearly that on the pie charts, the black section makes a right angle, right? So if we have a right angle, that means out of the whole pie chart, the whole circle, which represents 360 degrees. Our right angle represents 90 degrees, and therefore the fraction is going to be our 90 degrees over the entire 360 degrees. And therefore 90 over 360, take out common factor of 10 or cancel zeros, 9 over 36, which is 1 over 4. So a quarter of these people owned a black car. And now we're told that given that 5 people owned a white car, how many people owned a silver car? Okay, so there's a couple parts to this question. So let's try and take it step by step. And let's create some room, okay? This is going to be a bit of working here. So we're told that 5 people owned a white car. So where's the section that represents white cars? It's over here. So the first step to working this out is we need to understand how many degrees this white section takes up. Now, we're not really told, but using our knowledge of pie charts, we can see that this section should be around 30 degrees, right? Because we have this right angle here, which again we know is 90 degrees, and it seems to be a third of the 90 degrees. So it's almost like this is split into 3, right? 1, 2, 3. So we can safely assume anyway that this white section is indeed 30 degrees of the entire pie chart. And that's really important. The reason it's important is because by working out how many degrees the white section represents, we can work out how many people were surveyed overall. How do we do that? Well, we use our knowledge again of pie charts. We know 30 degrees represents 5 people. But the whole pie chart is 360 degrees. And therefore, if we go from 30 to 360 by multiplying by what? 12. Then we go from 5 people to the number of people who were surveyed by also multiplying by 12, right? Whatever we do on one side, we do to the other in this case. So we simply scale up the 5 people, multiply it by 12, giving us 60 people being surveyed. But then we're not being asked how many people were surveyed. We're being asked how many people owned a silver car. And we can see the key for the silver car is this striped pattern over here. So this is only going to be 180 degrees, which we can see. I put it in green, right? We can see this here is 180 degrees, or 2 right angles. So we know that 360 degrees represents 60 people. So how many people are represented by 180 degrees? Well, to go from 360 to 180, we divide by 2. So same thing here. We divide 60, make it a bit more clear. We divide 60 by 2. And dividing 60 by 2 gives us what? How many people? 30 people. So 30 people owned a silver car. So now for this question, how much will 46 lollipops cost if they cost £1.25 each? So here we have simple multiplication. We have £1.25 multiplied by 46. So the first step to make this easier for ourselves is to convert £1.25 into a number that's more manageable when it comes to multiplication. And that would be 125 pence, or simply 125. So we have 125 and we have 46. Let's multiply these two numbers together. And in this case, it's most likely smarter to do it using our column method rather than using mental maths. So here we have 6 times 5, which is 30, so 0, carry the 3. 6 times 2 is 12, add the 3, 15, so 5, carry 1. Then we have 6 times 1 is 6, add the 1, 7. Then we have the placeholder we place here. 4 times 5 is 20, so 0, carry the 2. 4 times 2 is 8, add the 2 we carried over, 10. 4 times 1 is 4, add the 1, 5. Okay, so we should have 0, 5, 7, 5, or 5,750 pence. And now we have it in pence, we can convert it back into pounds if we want to. And this would be £57, 50 pence. So here we have a very interesting question. We're told Jeff has 8 pizzas to share between himself and his friends. If each person is to get 2/3 of a pizza, that's a decent portion, how many friends can Jeff feed? So how can we work this out? We're going to use division of fractions. That might sound scary, but trust me, it's not that scary. We'll show you how right here. So if we think about it, let's say that Jeff had 8 pizzas and each person was going to get half a pizza. If that was a question, you would know straight away how many friends Jeff could feed, because we have 8 pizzas, each person's getting half a pizza, and therefore we have 16 people we can feed, right? But what are we doing there mathematically? If we have 8 pizzas and each person's getting a half of a pizza, we're dividing those 8 pizzas into slices of a half. We're doing 8 divided by a half. That's really what we're doing. And I'll prove that's what we're doing because whenever we have division of fractions, it's simply a multiplication in disguise. Why do I say that? Well, because we can change this divide sign. We can replace it with a multiply sign. And then what can we do? We can flip and switch around the numerator and the denominator. So now we don't have 1/2, we have 2/1. But can you see what we've done there now? We have 8 times 2, 1 times 1, we have 16/1 or 16. Remember we said that if Jeff had 8 pizzas and each person was to get half a pizza, then he could feed 16 people. We've come out with the same 16 here, which proves what I was saying, that really all we're doing is a division of fractions questions. Now, back to our actual question. And this time, we don't have Jeff giving each person half a pizza. We have Jeff giving each person 2/3 of a pizza. So we have 8, or 8/1, divided by 2/3 of a pizza, 2/3. And again, this is a multiplication in disguise. So now we have 8/1 times 3/2. We flip the numerator and denominator. And this leaves us with, numerator times numerator over denominator times denominator. So 8 times 3 times tables, 24. 1 times 2, 2. 24/2, 12. He can feed 12 of his friends. That's how we work this out. So you can see it's not that scary. All we have to remember is the golden rule. Any fraction division is a multiplication in disguise. So here we have some conversion questions. Bob is very proud of his new car. Well done, Bob. It is 370 centimeters long. Convert 370 centimeters into meters. So we need to know conversion. So we know 100 centimeters is 1 meter. And therefore, we divide this 370 by 100. Remember how we do it? 370.0, 2 bunny hops back. So we have 3.7 meters. And now for part B, we have convert 370 centimeters into millimeters. So what's the rule here? 1 centimeter is 1,000 millimeters. So now, to convert it into millimeters, we multiply by 1,000, or we add 3 zeros. So here it's going to be 370,000 millimeters. So here for question 23, we're told a recipe, and we have to work out how much of the ingredients we need for the cupcakes that we want to make. So if we know that in terms of flour, it takes 180 grams of flour to make 12 cupcakes. We can write it down. So we have flour and we have cupcakes, CC, cupcakes. It takes 180 grams of flour to make 12 cupcakes. But we're trying to work out how much flour we need to make 36, put it in red, 36 cupcakes. Well, what do we do here? Well, to go from 12 to 36, we can multiply by 3. And therefore, we can do the same thing to go from the amount of flour we need for 12 cupcakes to the amount of flour we need for 36 cupcakes. We do 180 multiplied by 3. What's 18 times 3? Well, 18 times 3, 18 times 3 is 10 times 3 and 8 times 3. 10 times 3 is 30, 8 times 3 is 24. 30, 24, 54. So 180 times 3 is going to be 540. So therefore we need 540 grams of flour to cater for 36 cupcakes. So now for part B, we're told that Lucy has 1 kilogram of caster sugar. Given that she had plenty of all the other ingredients, how many cupcakes can she make? So we're only going to be limited by the amount of caster sugar that Lucy has. Nothing else. We have plenty of everything else. It's in abundance. So we need to work out how many cupcakes can be made with 1 kilogram of caster sugar. How do we do that? Well, we construct the same scenario here. It's all ratios. So we know already that caster sugar, CS, cupcakes, CC. What numbers do we know already? We know it takes 200 grams of caster sugar to bake 12 cupcakes. But we have 1 kilogram of caster sugar, which is 1,000 grams. We have to make sure we convert it. How many cupcakes does this give us? Well, here we multiply by 5 to go from 200 to 1,000. So here we're also going to multiply by 5, giving us 60. So this means she can make 60 cupcakes. Okay, so here for this question, we see we have to add some extra faces to this diagram here in order to make it a net of this right-angled triangular prism that we see up here. So first of all, let's take a look at what we have already in this diagram. We can see we have this triangle here, and then we have this rectangle over here. And if we look very closely, we should be able to tell that this triangle and this rectangle represents this face and this face around the back of this triangular prism. We can count the lengths of the sides to confirm. We see this triangle is 1, 2, 3 down, 1, 2, 3, 4 across, same here, 4 across, 3 up or down. And then this rectangle, put it in red, is 1, 2, 3, 4, 5, 6 across, and 1, 2, 3 down, which we see right here. 6 across, shown here, and 3 up or down once again. So if we go to our right-angled triangular prism, we've already done these faces in blue. So now we have to do the other faces in red, which is going to be this large face at the front, this other triangle, and then finally this face at the bottom. So let's get started on that. Let's do what's easy first, right? We have the other triangle on the other side, and this should be exactly the same as this triangle, but just on the other side of the rectangle. Pretty simple, right? So let's put that in right now. It's going to go 4 across, so 1, 2, 3, 4, and then 3 up. So let's join these together. Okay, so we have this triangle. Then let's put in this big face at the top, this one right here. We see that this one is going to be all the way, so 6 centimeters across, and then up. Do we know how far up it is? Well, right here it shows us it's going to be 5 centimeters up. So 5 up, 1, 2, 3, 4, 5, and 6 across, 1, 2, 3, 4, 5, 6. So it lines up perfectly. So let's draw this in. And visually, this should make sense to us, because if you imagine it, if we have this face at the top over here and we open up this right-angled triangular prism, then this face at the top should be pointing in this direction, right? So it makes sense that it's going directly up in this direction. And then finally, we have the face at the bottom. We can't forget that one. And that's the one just at the bottom here. We see for this face again, it's going to be 6 across. But then if you think about how far down it's going to be, well, it's going to be 4 centimeters down. That's the depth of the rectangle. So therefore we have the 6 across already, but we have to do 1, 2, 3, 4 down. So here, 1, 2, 3, 4, yes. And then all the way across. So this should be the net of this right-angled triangular prism. Just take it step by step, section by section, and we should come out with the correct answer. So here for this next question, we have which of these amounts is the cheaper? Circle your answer. On the left-hand side, we have 25% of £64. And on the right-hand side, in the right corner, we have 20% of £75. Show your workings. Okay, so we can actually use mental maths here. We don't have to go through the whole long process of doing 25 over 100 multiplied by 64 over 1. I mean, it would work, but we can save a lot of time by being smart and using mental maths. What do I mean? Well, we can actually work out 25% of £64 using standard percentages. And what that means is using percentages that we are very familiar with. And these would be percentages like 50%, 10%, 1%. So let's take this first scenario, for example, 25% of £64. Well, 25% is half of 50%. And we can work out 50% of £64 very simple or very easily, because all we do is divide by 2. So we have 50% of £64 being £32. And therefore 25% must be half of that, which is £16. So on the left-hand side, we have £16. And even easier on the right-hand side, because we have 20% of 75. Well, we know 10% is a standard percentage. We can work it out very quickly without much calculation, without much thought. That's going to be simply dividing by 10 or doing one bunny hop back, giving us £7.50. And if 10% is £7.50, then 20% is going to be double of £7.50 or £15. So we can see it's very close, but the boxer in the right corner just wins by £1 difference. The winner is 20% of £75. This is the smaller, cheaper amount. So now we have to fill in the gaps to answer this question. For part A, we're told something over 18 plus 1 over 18 equals 1 over 2. We can work this out by using our knowledge of fractions. Why? Because 1 over 2, yes, it's a half, but also it's simply telling us that our numerator, 1 in this case, is half of our denominator, 2 in this case. So that means on the left-hand side of this equation, we have something over 18 plus something else over 18. Our common denominator is 18, which means when we add these two fractions together, that common denominator will stay as 18, right? It's not going to turn into 36. That's not how fractions work. It will stay as 18. So we have something over 18. But now we go back to what we said over here. If we know for it to end up as a half, the numerator has to be half the denominator. This has to be 9. And if this has to be 9, this has to be 8, because 8 plus 1 is 9. So therefore, the gap has to be 8. 8 is our answer. And then for part B, we have something over 24 plus 1 over 3 equals a half. So we have the same scenario of a half, numerator being half of the denominator. The trick here is simply finding the common denominator and changing the fractions to fit that common denominator. And in this case, it's going to be 24. So we can transform 1 over 3 by multiplying both the numerator and the denominator by 8. This gives us 8 over 24. And now we have that common denominator. We know, put it in a different color, we know overall we want it to end up with 12 over 24 because that represents a half, where again the numerator is half of the denominator. Yes, understood? So, with that knowledge, we now know that this numerator, this gap, must be 4, because 4 plus 8 gives us that 12 that we were looking for. So the answer must be 4. This is our answer. Now, for this question, we have to work out the perimeter of the shape below. And these questions are all about finding the missing values. Okay, so we have the missing value here, and we have the missing value here. How do we work out what these missing values are? Well, we simply compare the other values that we see around the shape. So here we're told that the distance from here to here, or in other words, from here to here, is 8 centimeters. But here to here is only 5, which means the gap here to here must be 3. And we use that knowledge to fill in this value here, 3 centimeters. And much the same thing to work out this missing value. If this is 12, but all of this is 20, then this remaining part here must be 8. And therefore our missing value over here is 8 centimeters. And now we have everything we need to work out the perimeter, because the perimeter, remember, is the distance around the outside of the shape. We must cover every single side of the shape. So here we have 20 plus 5 plus 8 plus 3 plus 12 plus 8. So let's be careful, not make any silly mistakes. So 0 plus 5 is 5. 5 plus 8 is 13. 13 plus 3 is 16. Plus 2 is 18. Plus 8 is 26. 6, carry the 2. 2 plus 2 plus 1, 5. 56 centimeters. That's how we can work out this perimeter question. So here for our final question, we are told to take a look at some of the deals that these vendors are giving us. So let's see how good these deals are. And in fact, we're told if we needed 3 tickets, we have to rank the vendors from cheapest to most expensive. So let's go through these vendors and let's see which one gives us the best deal, the best bang for our buck. So each ticket costs £480. So super tickets, buy 2, get 1 free. That kind of works for us because we need 3 tickets, right? It's us and 2 friends. So we can buy those 2 for 480 times 2, which gives us £960. And we get the third one free anyway. So we get the third one free. So overall, we get 3 tickets for £960. So let's just put the 960 right next to super tickets so we know very clearly how to compare these things. So super tickets, £960. Tickets are us. Buy 3, get 25% off total price. Awesome, let's see. So 48 times 3. We're going to do that so we can work out 480 times 3. Well, we have 50 times 3, giving us 150. But then we're not doing 50, we're doing 48. So from 150, we have to subtract the 2 difference multiplied by 3. So we subtract 6. So mental maths, we see 48, we think, okay, 48 is very close to 50. 50 times 3, 150. 150 minus the difference between 50 and 48, 2 times 3, 6. So we have 150 minus 6, 144. So 144, but of course it's not going to be 144, it's going to be 1440 or 1,440. But then we're told if we do this and we buy these 3 tickets, we get 25% off the total price. So how much do we get off? Well, what's 10%? It's going to be 144. So 5% is going to be half of that. It's going to be 72. And then 20% is going to be double that, which is going to be 288. So now we have all the components we need for 25% off. It's going to be this one plus this one. So let's add together 288 and 72. We could do it the normal way. So we have 8 plus 2 giving us 10, so 0 carry the 1. And then we have 8 plus 7 giving us 15, add the 1, 16. And then we have 2 plus 1 giving us 3, so 360. Or we could say that 288 plus 72. Well, we already have the convenient 8 and 2 giving us 10. So really it's just 280 plus 70 plus 10. So 280 plus 70, 350. 350 plus the 10 because we have the convenient 8 and 2. How convenient. Gives us 360. Either way, we get 360 off. So now we can work out the actual price. So we subtract that 360 from the 1440. 0, 0, 0. 4 minus 6 we can't do. So we take a 10 from the 4. 14 minus 6 gives us 8. 3 minus 3, 0, 1. So 1,080. So it's more expensive. And of course, another way we could have worked this out is instead of working out 25% and taking that off the total price, we could have simply worked out 75% of the total price from the very beginning. And in fact, in this particular case, it might have even been quicker to do it that way. But either way, it's good practice to know various methods to work out the same kind of question. So let's now move on to ticket galore. Let's clear up this space. Let's create some room. So what is ticket galore's offer? Buy one, get two at 40% off. Okay, so now we can use our technique that we described up here. Buy one for 480, cool. And then get two at 40% off. So two would cost us 960. But if we're getting 40% off, then that means we're only paying 60% of the actual price, right? So now let's work out that 60%, 60 over 100, that we're paying of the 960. So let's do some cancellation, some simplification of fractions. So first we can divide across this vertical, or we can take out rather a common factor of 10 and cancel those zeros. Then we can also take out the common factor of 10 across this diagonal. Because remember, we can only take out common factors across the verticals here or the diagonals here. We can't do it horizontally. So we have 60 over 100. Those two zeros can cancel. Then here we can cancel out these two zeros. And we're left with 96 times 6, or 6 times 96. That's how much we're paying. Well, here we can do 6 times 90, giving us 540. And then 6 times 6, giving us 36. So 540 plus 36 is 576. So if we add these two together, we have 6 plus 0, or 0 plus 6, giving us 6. 8 plus 7 giving us 15, so 5 carry the 1. 1 plus 4 plus 5, 10. So 1,056. So it seems like currently super tickets truly are super. They're giving us a super price. So let's see if top tickets come top of the list. Buy two, get one half price. Well, it's not going to, we already know it's not going to be the cheapest, right? Because super tickets gave us buy two, get one free. This one is buy two, get one half price. So we already know that super tickets wins, but in order to work out the general order, we still have to work out how much this is going to be. So buy two, that will cost 960. Get one half price, which is 240. 960 plus 240. Well, it's going to be 1,100 if you do 900 plus 200. And then 60/40 is 100, so it's going to be 1,200. Mental maths. It will help you in your exam. Now we can rank this. If we get a quick drum roll, the cheapest provider, the cheapest vendor is going to be Super Tickets. Let's put it number 1 here. Then we have Tickets Galore, Tickets R Us. Finally, Top Ticket, which was actually bottom ticket in this question. So that's our answer. That's how you work it out. And that is the end of this paper. Okay, so that is all for today. Make sure you like the video, subscribe, and turn on notifications so that you're the first to know when the next video is released. And on that note, I will see you all next time.